Hello, science enthusiasts. Today we're diving into the super cool world of refrigeration. Specifically, we're going to talk about something called head pressure. Now, what is that? Think of it like the blood pressure of your cooling system. In a water-cooled condenser, which is a key part of many large air conditioning and refrigeration systems, head pressure is the force of the hot, gaseous refrigerant pushing to get out. This pressure is super important. It tells us how hard the system's compressor is working to move heat from inside your building to the outside world. Science. Keeping this pressure just right is the secret to an efficient and happy cooling system. The condenser's job is to take that hot, high-pressure gas from the compressor and turn it back into a liquid. It does this by using water to absorb the heat. The head pressure directly affects how well this heat transfer happens. If the pressure is correct, the refrigerant changes from a gas to a liquid at the right temperature. This allows the whole refrigeration cycle to work smoothly, just like a well-rehearsed dance. It's all about balance and thermodynamics. So why does this matter so much? Well, a stable and correct head pressure means your system isn't wasting energy. It's running at its peak performance. This saves electricity, which is good for your wallet and good for the planet. It also helps all the parts of the system, like the very important compressor, last a lot longer. When things run as they were designed to, they don't wear out as fast. It's like not revving your car's engine all the time. It just makes everything last. Consider this: science is all about efficiency. Think about it this way. The head pressure is a key indicator of the system's health. It's a number that tells a story. By monitoring it, technicians can understand what's happening inside the pipes and coils. It's a diagnostic tool. A steady head pressure means everything is likely A-OK. An unsteady or incorrect pressure is a sign that something needs attention. So, understanding and controlling head pressure isn't just for experts. It's a fundamental part of making sure our cooling technology works for us in the best way possible. Now let's explore what happens when head pressure isn't just right. First, let's consider high head pressure. This is a common problem. It means the refrigerant gas is having a tough time condensing into a liquid. It's like trying to push through a crowded doorway. The compressor has to work much harder to push the refrigerant through the system. This extra work uses a lot more electricity, which makes your energy bills go way up. It's just not efficient at all. The system gets stressed out. When the compressor is constantly overworked due to high head pressure, it can get very hot and wear out prematurely. It's the heart of the system, and if it fails, you're looking at a very expensive repair. High pressure can also lead to other components failing, like pipes or seals, because they aren't designed to handle that much force. In extreme cases, safety valves might have to release refrigerant to prevent a dangerous pressure buildup. That's bad for the environment and for the system's performance. High pressure is a clear signal that something is wrong. On the other hand, what if the head pressure is too low? This might sound like a good thing, like the system is taking it easy, but it's actually another problem. Low head pressure means the refrigerant is condensing too easily, or at too low a temperature. This can mess up the whole system. The special valve that controls refrigerant flow into the evaporator, called the thermal expansion valve or TXV, might not work correctly. It needs a certain amount of pressure difference to feed the right amount of refrigerant. If the TXV doesn't get enough liquid refrigerant because the pressure is too low, it can starve the evaporator. This means not enough cooling happens where you want it. Your air conditioner might blow warm air, or your refrigerator won't get cold enough. It can also cause the liquid refrigerant to get back to the compressor, which is a big no-no. Compressors are designed to compress gas, not liquid. Trying to compress a liquid can destroy the compressor in an instant. So, you see, both high and low pressures are a problem. It has to be just right. So, we know we need to keep our head pressure stable. How do we do that? There are a few clever methods engineers have designed. One way is to control the fans on the cooling tower, which is where the water that cools the condenser gets cooled itself. By speeding up or slowing down the fans, we can change the temperature of the water going to the condenser. Colder water will lower the head pressure, and warmer water will raise it. It's an effective method, especially for larger systems. Another method involves using a bypass line. Imagine you have a pipe that lets some of the warm water coming out of the condenser mix back in with the cool water going into it. By using a valve to control how much warm water is bypassed, you can precisely manage the temperature of the cooling water. This helps keep the head pressure from dropping too low, especially in colder weather when the cooling tower water might get very cold. It's a simple but smart way to maintain balance within the system. A third way, often used on systems that need to run all year round, involves something called condenser flooding. This method intentionally lets some of the liquid refrigerant back up, or flood, into the bottom of the condenser. This reduces the available surface area for condensing the hot gas. Less surface area means the pressure will stay higher, even when the cooling water is very cold. It's like making the condenser smaller on purpose to keep the pressure up during winter. It's a bit more complex, but very effective. But one of the most common and direct ways to control head pressure in many water-cooled systems is by using a special valve. This valve directly controls the amount of water flowing through the condenser. More water means more cooling and lower pressure. Less water means less cooling and higher pressure. This device is called a water-regulating valve, and it's a key component for many systems. It acts like an automatic gatekeeper for the cooling water, responding directly to the pressure of the refrigerant. It's simple, reliable, and does a fantastic job. Let's get up close and personal with the water-regulating valve. This is an amazing piece of mechanical engineering. It works without any electricity. The valve has a bellows or a diaphragm inside that is connected to the refrigerant line. As the head pressure from the refrigerant gas pushes on this bellows, it moves a plunger inside the valve. This plunger is what opens or closes the path for the water. It's a direct mechanical connection between the pressure we want to control and the water flow that controls it. Here's a step-by-step on how it works in your system. First, a technician sets the valve to the desired head pressure using an adjustment spring. This is the target pressure we want to maintain. Now let's say the building gets warmer and the cooling system starts working harder. This creates more hot refrigerant gas, and the head pressure starts to rise. This increased pressure pushes on the valve's bellows, which in turn opens the valve wider. More cooling water flows through the condenser now. As more cool water flows, it does a better job of absorbing heat from the refrigerant. This causes the refrigerant to condense more easily, and the head pressure starts to come back down. As the pressure drops toward our target, the force on the bellows gets weaker. The adjustment spring then pushes back, causing the valve to start closing again. This reduces the water flow. The valve is constantly making these tiny adjustments, opening and closing just enough to keep the head pressure right where we want it. This continuous automatic balancing act is what makes the water-regulating valve so brilliant. It ensures the system uses only as much water as it needs, which saves water and energy. By following these simple principles, the valve maintains stability. Keeping head pressure steady is vital for the health, efficiency, and longevity of any water-cooled system. It ensures the compressor isn't overworked, the expansion valve functions correctly, and you get consistent, reliable cooling. It's science in action, making our world a more comfortable place.